All right, so what happens at the beginning of every topic that we've dealt with, we have to deal with the vocabulary. So now we have to figure out what is a polynomial. Well, a polynomial is a combination of algebraic terms. It's made up of constants and variables and exponents. But the key here is that they are separated by addition or subtraction. And this is what it looks like. 3x to the fourth plus 2x to the third. You've seen many of them through the years, but this is a polynomial. It has four terms. There's 1, 2, 3, 4, and they're all separated by addition or subtraction. So this is a polynomial. But we have a lot of vocabulary we need to get through. So let's think about this. The first thing we need to recognize is the leading coefficient. And the leading coefficient is the coefficient that is in front of or multiplied by the variable with the largest exponent. And in this polynomial, the largest one is x to the third. So the leading coefficient is 2. Now, -5 and -2 are coefficients. They're sitting in front of a variable, but they're not the leading coefficient. What is 5? Well, it's a constant because it doesn't have a variable. So again, we have all of this vocabulary that we actually have to understand. Another level of understanding that we have to get to is what is the degree of the polynomial? Well, the degree of the polynomial is 3 in this case because that is the largest exponent of the variables. The largest exponent of the variables. What are the exponents? Well, there's a 3, there's a 2, and of course everybody knows there's a 1 right there even though we don't see it. So the largest exponent is 3. Therefore, this polynomial has a degree of 3. The next thing we need to understand is term. Term means each of the pieces. This one has 4 terms. Do you see them? They are separated by negatives and positives, aren't they? So we have 1, 2, 3, 4 terms. Right? So what's the name of this polynomial? Well, you should remember that if you see x to the third, something should pop into your head. The highest exponent is 3, and you are supposed to remember that if the highest exponent is 3, that's a cubic. You're even supposed to know what it looks like. It is supposed to be a kind of a squiggly looking S shape, isn't it? So the degree is 3, and you're supposed to know that it's a cubic. So what are some of the degrees that I should already know? Well, x to the third is a cubic, and you're supposed to remember it's kind of an S shape. X squared is a quadratic, and you're supposed to know that's a parabola, or it looks like a U. What if it's just a plain ordinary x? Now, what is the exponent of that x? It's 1, isn't it? So what if it's just an x? That's linear, and you know that's supposed to be a line. So there are some things you already know. All right, so what could be the name of this polynomial? Well, the name of this polynomial is, it has a degree of 3, so that's a cubic. But how many terms does it have? 1, 2, 3. If it has 3 terms, it's a trinomial. So let's discuss what those prefixes might mean. Well, poly means many. You're supposed to already know that. And it could look as big as this, polynomial. What does mono mean, though? Mono means 1. So a monomial only has 1 term. Now I'm looking at these and there's lots of numbers and lots of exponents. Why is this only a monomial? Do you see any pluses or minuses between these? Nope. So these two examples are monomials. They're not separated. What does bi mean? Bi means 2. It's a bicycle. It has 2 wheels. So a binomial has two terms. This one has x squared plus 2, two terms. And of course, what does tri mean? Tricycle, triangle, it means 3. So a trinomial means it has 3 terms. Now let's be careful and not confuse degree with number of terms. Let's look up here, right here. The degree of this is a 2, which means this binomial is a quadratic. Let's look down here. This degree is 2. So this is still a quadratic, but it's a trinomial because it has 3 terms. Wow, lots of language. I thought this was a math class, didn't y'all? So our polynomials generally have 2 terms. The degree tells you what kind of expression it is. This is a cubic. The number of terms tells you it's a trinomial. So we have lots of language that we have to do. So let's glance over a couple of quick things just to review. Let's say I have 6. That's all I have is a 6. What is the degree? Well, it's 0 because there's no variable. There is no variable. So the degree is 0. So this is a 6. It's a constant. I also need to think about how many terms are there. Well, there's just one. There's just a number, so that's a monomial. Look at x plus 3. What is the largest exponent? Well, you're supposed to remember there's a little 1 right there, isn't there? So the largest exponent is a 1, and we're already supposed to know that's a linear, isn't it? But how many terms does it have? Well, it has 2 terms. It has an x and a 3, so it has 2 terms, therefore it's a binomial. Let's look at this last one. What is the degree? What is the largest exponent that you see? It's that little 3 right there, isn't it? That means the degree is 3, and if the degree is 3, it's a cubic. Now, how many terms does it have? Well, it has 1, 2, 3. It has 3 terms, therefore it's a trinomial. Lots and lots of language. Okay. We could also use some of these words to describe which piece we're looking at. If I needed to tell you which piece I was looking at, it would be hard to do, but I think I have some words that will help. For instance, if I was talking about 2x to the third, well, that's the cubic term because that's got the cube in it. Well, then what do you think this one's going to be called? Well, that's going to be called a quadratic. What's that one going to be called? A linear. And of course, what is plus 5? We're still talking about a constant there. It doesn't have a variable. All right. Standard form means show the terms in order of descending exponents. Now, you've done this all your life. This is nothing new, but let's just make it a fast and hard rule. I need to put them in order of descending exponents. In other words, they need to go down, don't they? So looking at this polynomial that I have right here, which term really did belong first? The first term really should have been 3x cubed. What should go next? Well, the next one should be x squared. See how we're descending? This was 3. This was 2. All right, now, do I just write these down? What I have left here, I have a negative 4x and a plus. Do I just write those down? No. I need to do combining like terms, don't I? Negative 4x plus 2x. I need to combine like terms and just write down what I need to write down, which is negative 2x. All right. Adding. Well, this is nothing new. This is combining like terms, isn't it? But what I do want to say is all of these may have parentheses when you start. Why do you need parentheses? Well, you need parentheses when there's something that needs to be done. You need to distribute, you need to do something. But I'm looking at this and I'm not seeing anything that I need to distribute, really. So I don't really need the parentheses. I can get rid of them. And now I can see and combine like terms, can't I? So this is negative 8d cubed. This is negative d cubed. I combine those. I think I get 9 of them. Negative 9d cubed, negative 7, negative 6, negative 13. The name of this is a cubic because it has a degree of 3. It has 2 terms. It's a binomial. Subtracting, you need to think a little bit harder because you need to ask yourself again, is there anything to distribute? Yes. See that negative right there? That negative is really a negative 1 sitting there, and that needs to be distributed, doesn't it? It needs to be distributed to both pieces. So now what I have, I didn't change anything in the front because there wasn't anything to distribute. But negative times 3c squared is negative 3c squared. And negative times negative 7 is positive 7. This is going to hurt you. You're going to forget to distribute, and that's going to hurt. Now I combine like terms, and the name of this one, the degree is 2, therefore it's a quadratic. It has 2 terms, which makes it a binomial. All right, so I've done all this so that I can start finding perimeters. Well, how do you find a perimeter? Add up all the sides. Don't try to look for a formula or whatever. A perimeter means add up all the sides. That's what perimeter is. So all we're going to do is just line everything up. We're going to add up all the sides. And what do we do now? We just leave it? No, I don't think so. How about we combine like terms? Isn't this just combining like terms? It's just what it is. Well, I have some x squareds. I have some x's. And I have some numbers. And I add them all up. And this is the perimeter of my figure. What is its name? Well, I see a degree of 2. That makes it a quadratic. I have 3 terms, and that makes it a trinomial. There we go. All right, you have a couple of practice problems you need to take care of, and we've done very well. So what would Commander War say? Quack, quack!